Hello, everyone, and welcome to the Biotechnology for the Built Environment Summit of 2021. So, let me just, there we go, for 2021. So the host of this summit is the Hub for Biotechnology in the Built Environment. And as those of us that have been to the first 2 days, you will know that there are 4 themes associated with the Hub for Biotechnology in the Built Environment. There is the microbial environments theme, which you heard from on Tuesday. There's a living constructions theme, which you heard from yesterday. And I'd like to thank everybody who was involved in those 2 days. Today, you will hear from the building metabolism theme. And tomorrow, you'll hear from the responsible innovations theme. So I'm the chair of today's sessions. My name is Gary Black. I'm Professor of Protein Biochemistry at Northumbria University, and I'm the co-director of the Hub for Biotechnology in the Built Environment. The Hub, as you've heard before, is a strategic partnership between Newcastle University and Northumbria University, and it's funded by Research England via its Expanding Excellence in England, the E3, as it's known, fund. So before I jump in and tell you what the building metabolism theme is all about, I just want to make a little plea that everybody can engage with us during these talks. So if you're watching us on YouTube, which the vast majority of people will be, then please pop your questions into the YouTube chat. They will be relayed to me, and I will make sure that those questions are asked at the end of the presenter's talk. So please do that. And please do that as you think of questions. Please pop them in the chat, giving us time to collate those questions for the end of the talks. Please also engage with us using social media, and please follow us on our YouTube channel. If you need any more information about schedules and other relevant information about the summit, then please, you can find those on our website, hbbe.ac.uk. Okay, so what is the building metabolism theme? Well, as you've heard already, the vision of the Hub for Biotechnology in the Built Environment is the development of biotechnologies to create a new generation of living buildings which are responsible and responsive to their natural environment. They're grown using living engineered materials to reduce inefficient industrial construction processes. You've heard from the living construction theme about that yesterday. They metabolize their own waste. They reduce pollution, generating energy and high value products. And that is all about what the building metabolism theme will present today. And they modulate their microbiome to benefit human and ecological health and well-being. And you've heard from that theme on Tuesday. So what do we mean by waste? Well, we're actually interested in household waste in particular. And we define household waste as food waste, garden waste, plastic waste, paper cardboard waste, wastewater, and human waste, sewage. So how do we metabolize? How do we valorize waste? Well, we do that by making use of biology and design. Really important that we use design in our processes as well. And we do that to develop prototype experimental building systems that incorporate different types of microbial reactors. So how do we do that? Well, we use various different ways of doing that. We use enzyme discovery and engineering using, for example, in silico modeling and machine learning. And we're looking at, for example, lignin degrading enzymes. As most people will appreciate, a lot of domestic waste is lignocellulosic material. So understanding and optimizing lignin degrading enzymes, for example, is a very useful thing to do. We also are interested in the generation of robust synthetic microbes using synthetic biology and metabolic engineering, or engineering biology, as we tend to call it now. Most people are probably aware that E. coli is the host that most people use for expressing recombinant enzymes, but actually E. coli is unlikely to be the best microbe to produce these engineered enzymes in the actual applications that we're interested in. So, so we're very interested in looking at different synthetic microbes that will be or may be more robust than E. coli. We're very interested in bioprocessing development. We're interested in low-tech bioprocessing, for instance, anaerobic digestion of solid human waste, for example, where we're interested in more high-tech bioprocessing developing, such as microbial fuel cells for wastewater treatment, artificial photosynthesis. We're interested in sugar fermentation of food waste and garden waste, for example. We're interested in the gasification of plastics, which can be used for gas, which can then be used for gas fermentation. And all of these processes produce a wide range of high-valued products, such as electricity, methane, hydrogen, ethanol, etc., and obviously many other chemicals. And it's also important that we rethink the building infrastructure so that we are producing buildings that process their own waste. So they do that in situ rather than relying on centralized industrial infrastructures and waste treatment. So how do we do this? So we've done this by appointing a complementary team of fellows, which are permanent positions at the HBBE. And what I would like to do now is to just introduce you to this team. All of them will be presenting short presentations in the very last session today. And I'd just like you to introduce this team. So first on in the last session today is Paul James. Paul is a Vice Chancellor's Fellow at Northumbria University. He's interested in combining biochemistry, structural biology, and metabolic engineering to develop bacteria into programmable cell factories. His presentation this afternoon is entitled Development of Synthetic Biology Toolkits for Non-Model Organisms. And his talk is on between 3:45 and 4 p.m. this afternoon. We have appointed Dr. Shafir Kalathal, and Shafir is also a Vice Chancellor's Fellow at Northumbria University. He's an electromicrobiologist who's interested in the application of electric bacteria to produce either electricity from wastewater when using microbial fuel cells, for example, or value-added products from waste carbon when using artificial photosynthesis. He's presenting this afternoon at 4 o'clock, and his presentation is microbial conversion of sunlight and carbon dioxide into high-value chemicals. We've also appointed Dr. Warispreet Singh, who again is a Vice Chancellor's Fellow at Northumbria University. Waris is particularly interested in computational enzyme design for protein engineering, using a whole range of different computational techniques, such as molecular docking, free energy calculation, and quantum mechanical calculations. And these can be used to improve catalytic efficiency, and in particular, the catalytic efficiency of enzymes associated with waste valorization. Waris's talk is at 4:15 this afternoon, and his title is Rational Engineering of Enzymes for Improved Activity and Selectivity Using Computational Approaches. We've appointed Dr. Rajesh Bomareddy, and Rajesh is a Vice Chancellor's Fellow at Northumbria University as well. He has interests and expertise in upstream processing, metabolic engineering, and midstream processing, so fermentation technology as well. His talk this afternoon is on at 4:30, and his talk is about sustainable production of fuels and chemicals from waste carbon. We've also appointed Dr. John Allen, who is a postdoctoral research associate, he has a background in molecular microbiology, and he works with me. And John will be presenting some of the work that we're doing around the development of new microbial chassis and new enzymatic technologies for waste valorization. John's talk is on at 4:45, and John will also be giving a poster in the poster session at 12:30 to 1:15. And I'll talk a little bit more about the poster session in a few slides' time. The final talk today will be from Dr. Marin Sawa. Marin is a Newcastle University Academic Track Fellow, or NUAC Fellow, as the name suggests, based at Newcastle University. Marin has only recently started in the hub at Newcastle University and is a design-led biotechnologist who's particularly interested in photosynthesis. Her talk this afternoon is entitled Biodesign, Designing with Microbes to Devise Applications. And her talk will be on at 5 o'clock to 5:15 this afternoon. So prior to the talks from the fellows that are associated with the hub, there are 3 keynote talks. The first of which is by Professor John McKeon, and John is part of the Centre for Enzyme Innovation at University of Portsmouth. Interestingly, the Centre for Enzyme Innovation was actually funded by the same funding that we have for the HBBE, the E3 funding. And obviously there are some nice links between the HBBE and the Centre for Enzyme Innovation, especially around enzyme discovery and engineering. John's talk is about discovery and engineering of enzymes to break down natural and synthetic polymers. And that will be on at 11:30 to 12:30 and will follow this well. John's going to focus on finding enzymes from nature with the ability to break down polymers. And we'll also end with some of the latest techno-economic analysis of using enzymes in these processes. John will be followed by Barbara's talk, Dr. Barbara Imhoff from Liquefer. Barbara is a co-founder of Liquefer, and Barbara's talk is about metabolic processes in building systems. And Barbara's talk will be between 1:15 and 2:15 this afternoon. Barbara will focus on metabolic processes as loop systems, a biospheric approach, life support systems for space as a model for a closed loop system approach. And we'll finish with the discussion of projects that provide elements for attempting closing the loop. Our final keynote talk today will be by Dr. Liz Fletcher. And Liz is a member of the Industrial Biotechnology Innovation Centre, or IBIOIC, which is based in Edinburgh. And Liz's talk will be entitled Wealth from Waste, Growing a Sustainable Future with Biotechnology. And that will be between 2:30 and 3:30 this afternoon. Barbara will start with an introduction about what IBIOIC is all about, talk about waste and biomass, what a biorefinery is, and how engineering biology can be used in the biorefinery concept, and then finish with some case studies on companies valorizing waste and challenges ahead for the sector. Just a quick mention about the research poster session. As I've mentioned, John will be providing a poster as well as an oral presentation today, but also we have some posters from the PhD students that are associated with our fellows. So we have 4 additional posters. One from Toby, top left-hand corner here, who is the PhD student of Rajesh, and he will be looking at metabolic engineering and fermentation technologies. One from Mandy, who is a PhD student of Shafir, who will be looking at photosystems and how they can be improved. One from Matt, who is the PhD student of Paul, and very much looking at how we can use synthetic biology to genetically engineer geobacillus. And one from Sonia, who's a PhD student of Waris, and she'll be looking at computational engineering of an enzyme that's particularly interesting as far as biofuel production is concerned. So my final slide before I hand over to John is just to give you an overview of what's happening today. The welcome is nearly finished. I'll hand over to John. We'll then have, after John's presentation, we'll have lunch, but also please, if you have time, visit the research poster session. And what I should have said when I was talking about research poster session is that you should already have links for the Miro board that they're on. And beneath the posters, you should also have a link for a Zoom chat room, which will allow you to discuss with the poster presenters. So please do avail yourself of that if possible. After lunch, we'll hand over to Barbara. We'll then have a comfort break, hand over to Liz, another comfort break, and then we'll hand over to the short presentations that I've mentioned that are associated with the HBBE academics, the fellows.